Okay, there are three methods that we can use to solve a system of equations. We can solve by graphing. We can solve by something that's called the substitution method. And we can also solve by something called the elimination method, which is also known sometimes as the addition method. So in this video, we're just going to cover solving by graphing. So in the first example, it says we're going to solve each system of equations by using the graph. We've got four graphs here, so we've got four systems of equations. The first two here, I'll call this is graph 1, graph 2. In graph 1, we've got one of our special cases where a line was drawn, and then another line was drawn, but it happens to be the same line, and it was drawn right on top of it. So any point that works for one line is going to work for the other line. So for graph number 1, the solution is going to be infinite set of solutions. And it's going to be any point that works for the line 1 will work for the second line. Okay, so that's for graph number 1. Graph number 2. This also is a special case. These are parallel lines. Parallel lines never cross. And if they never cross, they never intersect, which means they never have any ordered pairs in common. So in graph number 2, this is going to be no solution. Graph number 3, that's this one here. We're looking to see where it crosses. This one is the case that we usually run into where it has one intersection point. And that intersection point is right here. So my answer or my solution to this system of equations would be the point 4, 0. For graph number 4, this is also one of our typical cases where we have one solution, and the solution will be where it crosses, where the intersection is. And if we look to see where that intersection is, it would be the point 0, -2. Okay, in this example, we're going to actually graph this by hand, and if we're very careful, we will be able to see where it intersects, which will give us our solution to this system. So in order to graph this, for me personally, I like to put it in y = mx + b form so I can see my y-intercept and my slope. So I'll call this line number 1, and the second one will be line number 2. So I'm going to put line number 1 in slope-intercept form, which means I'm going to isolate the y. So that means I'm going to subtract x from both sides and then divide both sides by -2. When I do that, I get 1/2 x + 2. So I know for this line, my slope is 1/2 and my y-intercept is 2. So I'm going to very carefully draw this line on my graph. And I want to do it carefully because if I'm off a little bit, it will be hard to see where my intersection point is since we're doing it by hand. Okay, so it's crossing at +2 on my y-axis. And my slope is 1/2, so that means I'm going to go a vertical change of 1. I'm going to go up 1 and to the right 2. Up 1 and to the right 2 and make my steps. Up 1 and over 2. Up 1, over 2. So if I draw this with a nice steady hand, it's going to look like this. This will be my line 1. Line 2, I have -5x plus 2y is equal to negative 4. I want to put this in y equals mx plus b form, so I want to isolate my y. I am going to add 5x to both sides and divide both sides by 2. So I know for this line, my slope is 5/2 and my y-intercept is negative 2. So I'm going to cross down here at negative 2, and my slope means I'm going to go up 5 and over 2. So I got a vertical change of positive 5, a horizontal change of positive 2. So 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. So if I draw it with a nice steady hand, not very steady, but I tried. Here's my line 2. Now you can see where they cross, they have the same point right here. It's the point 2, 3 where they cross. So this should be the solution. We can check it by plugging in and making sure that it works in both equations. If I plug into equation 1, 2 for x and 3 for y, I get 2 minus 2 times 3 is equal to negative 4. That gives me 2 minus 6 is equal to negative 4. That one works. Now if I plug it into equation 2, I'm going to plug in 2 for x and 3 for y into equation 2. That gives me a minus 5 times 2 plus a 2 times 3 is equal to negative 4. This gives me a negative 10 plus 6 is negative 4. So that works as well. So we solved it graphically. And if you're really careful and you use grid paper, you'll be able to see where they cross. And then you can check it by plugging back in. Now, there is the intersection method on your calculator as well. I'm putting that at the end of this lesson, so if you want to refresh on how to use the intersection method on the calculator, you can do that, and you can check your answer graphically as well.